Calle. అందరిది మీద సార్ ఇది రాఘవారికి మీద అదే సార్ది వీడియో ఆఫ్ చేయలేదు కదా.
స్టార్ట్ చేద్దాం, కొంచెం టైం అవుతుంది.
సరే స్టార్ట్ చేద్దాం సార్, ప్లీజ్ మీరు స్టార్ట్ చేసేది సార్.
అంటే 32 మంది ఉన్నారు.
ఒక్క నిమిషం సార్, నేను అమ్మాయికి చెప్తాను, తను ఇన్వైట్ చేస్తాను. అందుమంటే అది సార్ ఒకసారి సార్ అవును తక్కువ మంది ఉన్నారు, దానిలో ఒక ఎందుకంటే మనం అనుకున్న టైం స్టార్ట్ చేద్దాం.
A very good morning to one and all. In line with state government's initiatives to enhance skill sets in quantum technologies and computing, Center of Excellence on Quantum Science and Technology, JNTU Kakinada, is organizing a series of expert lectures on quantum science and technology, commencing from 4th April 2026. I, B.S.V. Kiranmay, Assistant Professor, CSE Department, University College of Engineering, Kakinada, JNTU Kakinada, am to today's expert lecture on quantum computing from qubit to real-world impact, a transformational journey. Quantum computing represents a fundamental shift in how we process information. This emerging technology is moving beyond theory into practical application. Quantum computing has the potential to transform the fields such as healthcare by accelerating drug discovery, logistics by optimizing complex systems, and cybersecurity by redefining data protection. Now, I request our Honorable Vice Chancellor JNTUK, Professor CSRK Prasad Garu, to address the aspirants. Good morning, sir. Please.
Yeah. Good morning, all. Good morning, Avinash, Dr. Avinash. Thank you for accepting our invitation and sparing your valuable time to give a talk on quantum computing from qubits to the real world impact, a transformational journey. In fact, the JNTU Kakinada has established a center of excellence on quantum science and technologies. And as a part of the mission of this center, we would like to bring the industry persons, scientists, and the teachers, learners like students and research scholars on the same platform. They should also be exposed, especially the students of the JNTU Kakinada and also the faculty working in different affiliated colleges and also including our campus colleges. They should also expose to the new trends and happening in the quantum science and technology, because JNTU has established a center of excellence in tune with the objectives and mission of the policy of the government of Andhra Pradesh, where they are establishing a quantum valley at Amravati. In fact, they also started a Ratan Tata Innovation Hub at Amravati. And then there are 5 spokes, starting from the Visakhapatnam, Rajahmundry, Vijayawada, Tirupati, and Anantapur. And JNTU Kakinada is fortunate and also happy to associate with the RTH as a knowledge partner. So, as a part of this RTH, and in order to be part of the policy of the government of Andhra Pradesh, JNTU Kakinada has established a center of excellence in quantum science and technology. In fact, I am happy to announce that the DST also gave a project to the JNTU Kakinada to establish the UG laboratories in the quantum technologies. So UG teaching laboratories. So those things will be shortly. We are going to establish a laboratory. Probably the facility will be extended to all the people working within the university and as well as the affiliated colleges. So, whereas this series, I appreciate Professor M.H.M. Krishna Prasad, who is the coordinator of this Center of Excellence, for his initiation, and he trying to rope in several experts working in the industry as well as the scientific laboratories to give an opportunity for the students to learn and also create an awareness among the students what is happening across the globe as well as across the India. And then the ultimate objective is we want to develop a more manpower and, in this quantum science area and create a skilled force which is required for the industry in the years to come. So I appreciate the Professor Krishna Prasad and his team for this wonderful initiative. This is the first in the series of the expert talks in the quantum science and technologies on various aspects of the quantum science technology on various verticals, themes and sub-themes. The expert talks will be arranged. So I hope and wish that the students as well as the scholars and then the faculty members working with us and they'll get benefited. I think we're given this the facility opportunity for anyone to register. Need not be the students of JNTK alone. Any common man public so they can register with this. I understand that there are about 700 plus registrations for this topic. So this itself shows that there is a lot of demand and a lot of enthusiasm among the students to learn the new technologies. So without wasting much time, I thank the Center of Excellence team for initiating such a wonderful program. And also thank on behalf of the JNTU Kakinada, Dr. C.H. Avinash, Scientist D, National Center for Medium Range Weather Forecasting, Minister of Earth Sciences, New Delhi, for kindly accepting to deliver the talk. Thank you one and all. I hope everybody will be enriched by hearing to his presentation. For the next 60 minutes, I think.
No, 1.5
hours. So next 90 minutes, we'll have a feast of learning the new things through the Dr. Avinash. Thank you one and all the best for all the participants.
Thank you, sir, for encouraging us in materializing the Center of Excellence the quantum science and technology in JNTU Kakinada. Now, let me take the privilege to introduce the resource person today, Dr. C.H. Avinash. Dr. C.H. Avinash is a scientist D at National Center for Medium Range Weather Forecasting, Ministry of Earth Sciences, Government of India, where he involved in advanced research in artificial intelligence, quantum machine learning, and generative AI applications for earth and atmospheric sciences. He holds a PhD in quantum machine learning from the Indian Institute of Space Science and Technology, where he collaborated with the Indian Space Research Organization ISRO on advanced research initiatives. He earned his MTech and BTech in computer science and engineering from JNTU Kakinada, Andhra Pradesh. Earlier, Dr. Avinash served as assistant professor and associate professor in Department of Computer Science and Engineering at Gayatri Vidya Parishad College of Engineering. During his period, he actively fostered academia-industry collaboration by leading consultancy projects, mentoring student internships, and partnering with software companies to implement practical tech-driven solutions. He has received prestigious fellowships and research grants from institutions such as IIT Palakkad, Technology iHub Foundation, and AICTE in recognition of his impactful work in AI, machine learning, and quantum computing. Dr. Avinash's research interests include generative AI, quantum machine learning, deep learning, big data analytics, and their real-time applications in weather forecasting, healthcare, and autonomous systems. He is an active member of IEEE and Computer Society of India and serves as a reviewer for top-tier IEEE journals and conferences. He also has been involved in organizing major IEEE technical events and conferences. He is currently engaged in collaborative research with scientists from across India and abroad, and he is open to formal collaborations in areas such as generative AI, product development, quantum algorithms, and real-time AI deployments, contributing to the advancements of India's AI and quantum technology ecosystem. I welcome Dr. Avinash to share his expertise and experience in quantum computing. Welcome, sir.
Thank you, ma'am. Thank you for the kind introduction. And I also thank Honorable Vice Chancellor of JNTU Kakinada for his uh, initiative in inviting me and this lecture series and this Center of Excellence on Quantum Science and Technology. I think this is the need of the hour. And I'm very happy to contribute to this series of lectures. Because I was the student of JNTU Kakinada, as ma'am told, and I have been associated with Dr. M.H.M. Krishna Prasad since 2010. He was my MTech. He was my MTech project guide, along with Dr. Srinivas sir, then HOD of Computer Science. So from 2010, I should say that Dr. M.H.M. Krishna Prasad is is being my mentor, and he continuously gave his support and moral support, and whatever that I am enjoying now as in my career is he has a big role he played in my career. So thank you, sir. I would like to take this opportunity to thank you. And so uh, I'll start with the presentation. I'll tell the plan for today, because it's 2 hours of talk. I divided it into two parts. Maybe the organizers can give me a hint when should I break the session for 5 minutes or 10 minutes, or if it's not required, I can continue doing that. So I'll share my screen. Please confirm if I'm loud and audible, and my screen is visible.
Visible, sir. You may proceed.
Yeah, thank you, ma'am. Thanks for the confirmation. So I thought to give a brief introduction about why do we require quantum computing in this era of data-centric artificial intelligence, the models that are being developed, and the ability of artificial intelligence we are enjoying now. So all these aspects. So I thought to touch upon what is the requirement for getting into this quantum computing research or application development. So that's why I named this talk as "From Qubits to Real World Impact: A Transformational Journey." So before I start, I would like to thank all the teachers who gave me the inspiration to explore new technologies and all these things, like Krishna Prasad sir and JVR Murthy sir. He's also one of my inspirations. He's from JNTU Kakinada. I think he retired a few years back. And my guide, Dr. B.S. Manoj from IIST, and Dr. Raghavendra from ISRO. So all these people helped me to explore new technologies. And especially this quote is the inspiration for me to take up the quantum technologies back in 2018 when I started my research. So there are very few resources available for quantum things. And this particular quote by Richard Feynman, who is considered the father of quantum physics, is uh, inspired me a lot in order to take up this particular research area. So before I get into the actual topic, I would like to start with a story. I don't want to people to bore because of the continuous technology thing I'm going to talk. So let me start with a story. This is a story of a machine, and there's a disclaimer. So no machines were harmed. These days we cannot harm machines because they are very important to us now. Without ChatGPT and other AI tools, barely we cannot barely we can do our work, because they are helping us lot in speeding up our tasks and doing things in a very effective and optimized manner. So this is the story. So once upon a time, there is a big city. There was a big city, and people used to live very happily in that city with a machine. Because nowadays people are very happy with the machines because machines and artificial intelligence is taking most of the tasks, and they are able to save time, and they are able to invest their time in some other useful activities and research things. So they used to live happily with the machine, and the machine used to give all the answers to their problems. It used to help them, and it used to give multiple, support in multiple activities that they are doing. And of course, the machine constantly used to learn from the data uh, with which this set of people are interacting with, and all these things. So there is a hero for the story. Of course, without a hero, there won't be any story. So this guy is an ordinary student. He used to go to college every day, and he used to do the lab experiments. Uh, I mean, very normal life he used to lead during the first half of the film. So then suddenly there was a conflict. So you can consider this as an interval. So this machine started becoming inefficient. So there's a problem. So it used to behave very weird way. There is no answer. There's no enough efficiency that the people uh, were able to extract from the machine and all these things. So and that thing stopped. They couldn't even move a step because they are totally dependent on the machine. All activities stopped. Everything stopped. So now this hero is not an ordinary guy. He is not just doing experiments or superhero. He's going to transform from hero to superhero. He's actually building a box in the first half. So with lot of obstacles and lot of troubles, especially there will be a villain for this hero always. So money and time are the crucial things that this particular hero is going to, he used to face the problems with. And somehow he succeeds because of his friend, because always there will be some helping hand for the hero in the story. So his friend helped somehow with the things that he want to achieve, and suddenly they bring a helicopter from nowhere, and they'll attach this mystery box that this hero built with the existing machine. And then the machine started performing very better, and people started living very happily. So nowadays we should definitely have a part two for the story, because nowadays it's becoming mandatory that part one, part two kind of stories. So again, there is a cliffhanger now, but after few years, even this machine and mystery box are not sufficient with the questions and data that people are asking. So this is the story. Maybe part two is what I'm going to explain how to solve this cliffhanger. So I would like to relate this story to the technology developments that are happening. So the previous machine you can consider as CPU, and our hero is a GPU researcher. He used to build, GPUs which can process data very fast. And his friend is an investor in GPU companies. He has a lot of money and all these things. And this mystery box is nothing but the GPU cards, because only when the the development in hardware increased, so all the technology developments happened, like ChatGPT and all these things. So that's the reason why people are used to uh, developing much and more and more GPU cards, and these things. They started investing on these things. So this machine and mystery box are nothing but the CPU and GPU that we are using at present. And in the future, these things are also becoming inefficient, because with the amount of data that we are generating, the necessity of solving the complex problems and all these things. So we require some other technology as a helping hand with the existing technology. So people look at it as quantum computing. After a few years, we will have CPUs, GPUs, and QPUs, quantum processing units, which will help the existing, hardware. In addition to the existing hardware, these will be as a module attached to these existing hardware, and it will become much more complex, and it will solve complex problems. So this is the whole idea behind that story. So the existing CPU and GPU combination is not sufficient in the future to solve some problems. Not all the problems can be solved by quantum. So some problems which are complex and which are very specific to be solved can be solved using quantum computing. So it's like we cannot eradicate completely, or we cannot remove the existing entire infrastructure investment and all these things. So quantum computing comes as a module, and once we start using this module in addition to the existing things, you will be able to produce much more outputs and much more efficient algorithms or whatever. So with that, I would like to give the overview of my presentation today. So I'll be talking about the different success stories of machine learning and how agentic AI is, giving much more additional, what we say, uh, brilliance to the existing software and all these things, and existing limitations are also there, like I told in the story. So this data is becoming huge, and needs are becoming huge. So there are limitations for classical machine learning and all the existing technologies. Hence, people are looking at quantum machine learning. I would also like to walk you through different resources that are available on internet. So I thought not to give much theory. I thought to give you much information from which you can start doing quantum things and learn quantum computing. And you can also design curriculums with this information. You can also plan for how to introduce this course as a professional elective or something in your respective colleges and universities. So that's the whole idea of my presentation. So we are already enjoying this thing, the success stories of machine learning, because we have brilliant generative AI models, large language models, multimodal large language models, so which can produce code just by interacting with it, and which can write beautiful paragraphs, and very efficient way of drafting the documents and everything. Everything increased because of the technological developments, and the hardware developments happened over the past 5 to 10 years. So we are able to do data driven decision making, because with the huge amounts of data that we are processing, there the output of this data processing can be used for decision making. And predictive capabilities also increase like anything. The existing machine learning model, by the way, the machine learning, I mean, it's generative AI, everything. It's artificial intelligence. I use this term machine learning because most of the time we see data, the machines or the algorithms learning from the data and producing the outputs. So it's a generic term. So especially you can consider it as artificial intelligence. As machine learning is a popular and widely used term, I considered telling machine learning. So natural language, computer vision achievements, you can, even you see people producing movies out of this generative AI, and beautiful images, and very, very efficient and beautiful images with the diffusion models, and unbelievably good text with the GPTs. So agentic AI is now becoming very popular, where you can handle multiple things. If you want to use tools for your answer, agentic AI is there. If you want to get the answers from memory, agentic is there. And if you want to get the answers in a step-by-step process, planning and using the chain of thoughts, agentic AI is there. So that's how the existing machine learning things are working. And even the science is being discovered by agentic AIs. If you look at this particular paper from, I think this is from MIT, Psi Agents, you can take a look at this paper, uh, which talks about automatic scientific discovery. Like, if consider somebody is in initial stage of their thesis, figuring out the thesis topic, so he or she has to refer lots and lots of documentation on Google Scholar or whatever the publication houses that are publishing every month or every day, in fact. So continuously there used to be, uh, you know, uh, pressure on these people to refer multiple documents in order to come arrive at a particular thesis topic. So now even agentic AI is helping in that process, where you will be able to define multiple agents, and you can interact with those agents as a human. So if you see on the extreme right side here, so you will have this particular human in the loop, where there will be ontologist agent, planner agent, critic agent, scientist one agent, scientist two agent, and assistant. So all these talk to each other in in a particular group, and human will always be giving the inputs to the group, and continuously they will be able to find out some particular research topic in order to work on, and they themselves check with each other whether this topic is valid or not, whether it is useful or not, practically possible, practical possibilities and everything. So that's how the agentic AI is blossoming now. Of course, there will be certain limitations for any technology that at present we are using. So scalability is one of the biggest challenges, because huge tons of data, massive amounts of data sets are being generated. Your one day usage of ChatGPT itself is can be considered be a huge amount of data, and consider ChatGPT kind of hundreds and thousands of models on Hugging Face, people using them and producing data. So it becomes huge and massive, and often it reaches to certain stage where it cannot perform better anymore. So this is how the interval scene that I described. So complex optimization roadblocks are also there, because finding something of heuristic nature, a solution of heuristic nature, is not that easy in the available options that are extremely increasing because of the data that is being generated, and the solutions from which the options or that we are getting from that particular data out of the algorithms is also becoming very huge. Of course, huge data demands huge processing, and huge processing demands huge resources. And of course, it is time consuming because of the uh, volume of the data and all these things. So then people started looking at quantum computing as a you know alternative technology which can solve complex problems, which can actually handle huge amounts of data due to the intrinsic nature of quantum computers. Uh, so it has rapidly evolved now. So people consider this as second quantum revolution after the first quantum revolution in 90s, and this is the second quantum revolution, uh, 19th century, and this second quantum revolution now. So now I'll very briefly introduce what is quantum technology. Hope most of the participants already know what is quantum technology, and I hope people are already using it in their curriculum uh, as a part of their course or a topic or a lab. So, quantum technology, in comparison with classical computing, we can consider this classical computing of discrete nature. So, if you really want to do something classical, either you do it either using 0 or 1, it's discrete. You can directly say that, okay, this is 0 and this is 1. So that's how classical computing has a specific nature. So whereas quantum computing, it is both 0 and 1 at the same time. So if you are wondering how is it possible, this is because of the material science, discoveries in the material science. When people started, for processing data, for huge amounts of data to be processed, people started building chips with lots and lots of transistors. So to make much more efficient a particular chip, people started, imparting more and more transistors on it, and they reached a scale where if this further divide or further miniaturize that particular transistor, it started becoming uh, in a quantum nature. So then they went to subatomic level, and they started looking at what's happening at that particular level, and they discovered that to if we go to that level, usually the materials start behaving in quantum nature. So then they started discovering the materials which can intrinsically show this property in order to solve the problems which requires lots and lots of processing at the same time. So that's how quantum computing. Usually people say the coin toss example. So that's the same example I'm showing you here. So once you start doing quantum computing, so you will understand that it involves lots and lots of qubits and multiple states at the same time. So considering 2 qubits, you will have 2 power 2 quantum states. That's why if you have 1 qubit, you have two quantum states, 0 and 1. If you have 2 qubits, you will have four quantum states like cat 0 0, cat 0 1, 1 0, and 1 1. So this is all linear algebra. So I'm not completely getting into those details. I'll point you to the textbooks that you can use in order to look at those mathematical concepts that are useful for quantum computing. Without linear algebra, there is no quantum computing. So you can consider that's the reason why people are looking very positively for the applications of quantum in machine learning, because machine learning is all linear algebra. So once I stop, once I measure the qubit, it falls down to some particular state, either 0 or 1. Here, if you see it, it is mostly the second state. So this particular property is called as superposition of quantum bits, where the quantum bit will be in both 0 and 1 at the same time. So that's why they call it a superposition. There are other quantum properties like entanglement and interference. So, but I'm not going into those details at present. So I'm focusing on specific quantum concepts which are useful for quantum machine learning. So now coming to now we understood how the quantum bit, what is the nature of quantum bit, and how can we use this in solving some particular problems. So if you consider classical computing, to solve this particular thing, it acts in a brute force way. So where it searches for all the things. Whereas in quantum, if you see, it searches for the solution at the same time. So this is an example, example that depicts Grover's search algorithm. So where you will have, um, again, I'll try to play this, where in classical computing, you desperately try to achieve this, whereas in quantum computing, you will be able to observe multiple states at the same time. That's how you will be able to find out what is the solution. So this is the difference between classical computing and quantum computing. So I just wanted to show it in an example. So now coming to the theoretical comparison, how classical computing and quantum computing differs. So, in this particular thing, uh, again, so as I told, you will have digital bits where this will have a quantum bits, which will have superposition of both 0 and 1 at the same time. And now coming to the Moore's law, as I told, as you're trying to manufacture more and more transistors on the same chip, and you try to import more and more transistors on the same chip. So it started becoming quantum nature, and then people started looking at the subatomic level. And two power n states, one used at a time, whereas two power n states in parallel, as I told in the previous example. So you will be continuously exploring one by one in classical, whereas in quantum, you will be looking at all the possibilities at the same time. So, of course, nowadays there are different things that in classical we are parallelizing, but we cannot compare the classical parallelization and distributed computing kind of parallel computing kind of thing with quantum computing. The reason is that the physics behind this particular quantum computing parallelization and classical computing parallelization are totally different. So in fact, in classical computing, we are doing sequential computing, even though we are parallelizing it using multi-threads and other technology. Intrinsically, it is performing sequential computation when we talk about the material level. So whereas in quantum computing, it is inherently parallel. So if you see 0 and 1, it stays in the superposition of 0 and 1 at the same time. So that's the reason we are able to do one operation at a time. Here you can do millions of operations at the same time, depending on the availability of the qubits. So we have 64-bit computers, which has gigaflops capabilities, and if we have 30 qubits, we will get about at least 10 teraflops of capability in quantum computing. So now coming to the applications of quantum computing. So all these uh, intrinsic properties of quantum computing, we will be able to solve machine learning problems, telecommunication problems, especially for sending data safely with on a secure network. We can establish quantum channels. So I'll also touch upon how can you explore this quantum internet also. And as already Madam mentioned in the introduction, that it is used for drug discovery and drug development because of the intrinsic parallel nature of quantum. And cybersecurity and cryptography, of course, people are already using this. There are many quantum, uh, you know, uh, cryptography products. So post-quantum cryptography is a situation where people will be facing problems with the RSA, because with the ability of quantum to find the prime numbers very quickly, so all the public key cryptography systems will be cracked using quantum computers. That's why people started building algorithms which cannot be cracked by quantum computers also. So that's the main reason behind the applications of quantum in cybersecurity and cryptography, where people are developing post-quantum cryptography algorithms, which are quantum safe. That means once we get a full-fledged quantum computer, uh, if we use these algorithms to, transmit data or store the data or encrypt the data, you will not be able to uh, uh, lose the data because of a security attack or something. And of course, optimization is one of the major applications. That's why financial modeling will have quantum applications. So, of course, we are also exploring how quantum is useful in weather forecasting and computational chemistry, logistics optimization, aeronautics and space. Like NASA is already exploring how to, optimize their drones and all these things in order to schedule the flights and all these things in defense sector also. So there are vast and wide range of applications wherever you see parallelization and optimization requirements. There, quantum computing can help you in those applications. So coming to the global investments, left side, if you see till 2023, and right side is from 2023 till 25. So many companies started investing, and I'll also show what kind of jobs are being created using quantum computing in these companies. And I also walk you through different websites where you can actually apply these things also. So there are wide range of investments from different countries, and people say this quantum race. Whoever achieves this, quantum, or whoever wins this quantum race, they will have huge advantage in that. So that's why people started investing like anything on quantum. So there is no data from China. They keep it very confidential. That's why you cannot see it after 2023. So now we'll talk about quantum machine learning framework. I'm actually not getting into the complete basic details of quantum computing because you require a specific course in order to understand quantum mechanics before you start quantum computing. So I'll point you to those resources. There's one beautiful textbook which starts from inception till end. I'll point you to those textbooks. But for now, you understand that quantum computing is a mixture of quantum mechanics and computation. So that's the reason why we already know how computation works, and we should learn how this quantum mechanics can be used for computation. So further, there are good resources. I'll point you to those resources. So this is a simple quantum machine learning framework, beginners kind of thing, where you have huge amounts of data, and usually you pre-process this data before you do anything with the data. So most of the time, data scientists and machine learning engineers spend is on pre-processing of the data, and then anything that you want to process should be loaded onto the bits or qubits. So in quantum sense, we should load the data onto the qubits. So to load the data onto the qubits, we require quantum loaders. So quantum loaders are nothing but circuits. So all the things that we are talking about computation in quantum will be in form of circuits. So quantum loader itself is a circuit where it takes the data, and it keeps the data onto the qubits into the so that that data gets into the superposition, and that superposition will be able to the circuits on these qubits, which are where the data resides in superposition, will be able to process the data. The circuits will be able to process the data and get to some output. So now to process, you require a quantum machine learning algorithm. So again, this is nothing but a quantum circuit, and whatever we talk in quantum is in form of circuits, because these circuit consists of gates. So qubits are processed using quantum gates. So quantum gates are nothing but, again, those are matrices. And again, as I told, this is completely linear algebra, and any modification that we do on a qubit will be done using matrices. So those matrices are called as unitary matrices, and these unitary matrices are nothing but these are termed as gates. So I'll show all these things. And finally, once I load the data onto the qubits, once I process using quantum machine learning, now I need to use this processing. In order to use this processing, I need to measure the qubits. So qubit measurement is nothing but the once I press the stop button, if you saw the spinning coin stopped and it reached to some stage. So this quantum measurement is similar. So whenever you start processing the data and you try to measure it, so you are actually disturbing the quantum state that is in superposition of multiple states at the same time. That disturbance or that measurement itself gives you some deterministic value, and these deterministic values can be used for decision making or post processing or analytics. This is how the usual flow of a quantum machine learning framework would be. So in order to achieve this, one of the examples is hybrid classical quantum classical computing framework. So there are different variations: quantum classical, usually classical classical, quantum classical, classical quantum, and quantum quantum. So here I am focusing only on quantum classical computing framework, which is widely popular and being widely used, where you load the data onto quantum bits and the quantum circuits, and this variational quantum circuit is nothing but the quantum processing part that you are doing, and you are measuring. And if your output is not to the target, you will again go and update these variational quantum circuit parameters. As I told, this Q0, Q1, Q2 stands for quantum bits. The quantum bits are represented using ket. Q0, Q1, Q2, Qn. So these are the quantum bits, and U stands for unitary matrices. So U1 of x, U2 of x, U3, Un of x are nothing but unitary matrices acting upon that particular input value, which is on these qubits. So there are 2 qubit gates, single qubit gates. Here it is representing 2 qubit gates. And now once the data is loaded, you get a feature map. So once the data gets on to the quantum bits, it is considered you get a feature map of the classical data onto the quantum bits. And then there is variation circuit, V1, V2, V3, so on. And again, these are combination of single qubits and multi-qubit gates, but are actually parameterized. So here we are using parameterized in quantum classical computing framework because by observing the output, I will be able to go back and adjust the parameters. This is similar to your backpropagation framework, where you observe the output, go back, adjust the parameters, and again you get some output value. So this process continues until and unless your loss gets reduced. Okay, so this is the cost function. So you will be evaluating the cost function. So you'll be wondering how to execute this particular thing. So there are many frameworks and many companies that are already doing this, and I used mostly PennyLane during my research, and still I work with PennyLane because it's a quantum machine learning framework, and there is wide research community support for that package. Uh, and of course, the other things are also widely used, but I specifically prefer Pennylen, which is easy to work. So now, looking at the same similar framework, you have big data and you pre-process. There is nothing quantum in this. So big data and pre-processing is your own classical way of doing the things. Then started data encoding. Your quantum loading is done using data encoding of classical data onto quantum bits. And then this can be done using Penny all these steps, all this particular dotted box steps in the dotted box can be done using either Pennylen or Tensor Quantum, or there are multiple packages, but specifically I prefer these two. Pennylen is widely used, and so you have provisions to measure also, and then you can do the post processing. Now, how you will be wondering how to execute this on a hardware. So all these frameworks are equipped in such a way that they support both classical processing and quantum processing. So whenever your method hits the quantum function, so it directly goes to the quantum computer and it executes there, and it gives you the piece of output back to the your HPC or whatever high performance computing systems you are utilizing. Okay. So this is how the experimental flow would be. And quantum circuit development and simulation are possible using quantum. Of course, all these are functions that are being performed by these particular packages, Qiskit, Circ, and Pennylen. Multiple companies are involved in producing this. And these are the applications for which these packages are widely used. For QML research, Pennylen is leading all the research. So this is how the existing hardware. By the way, on the right side, the quantum computing thing. So there will be lots and lots of things that are involved. So quantum computer is a huge investment. It's not just a small thing that you can buy or some and use it. So it's a huge investment considering the superconducting qubits. There are other qubits also. I'll be explaining in the next slide. So based on that, your cost would be varying. So these are the different quantum bits that are available. Uh, costliest ones are the superconducting qubits. Also they are fast and they are scalable. That's why most of the companies invest in superconducting qubits. If you see IBM, Google, Rigetti, these people invest in superconducting qubits. Whereas other physics behind qubits is ion trap based quantum computers and neutral atom quantum computers. See, these are all, as I told previously, when we go to the subatomic level of the materials, uh, they start behaving in quantum nature. So people started discovering such materials using different combinations so that they behave in a quantum nature. Especially photonic quantum computers are becoming popular again. Xanadu is leading this, using photons as a fundamental qubit unit, because photons are again uh, ma'am, is there any doubt or okay? So photonic quantum computers, they use photons as fundamental qubit, and there are other technologies like surface dot quantum computers, laser cooled ion trap quantum computers, all these things. But computer science people mostly use either photonic quantum computers or superconducting based quantum computers. And for small experiments, uh, they also use NV center of diamonds. So that also I'll explain that. Now, if you're wondering where are we and is it really possible to do such kind of things? They are already in market and people started using them already and people started selling them already. If you look at this particular slide, we have different support hardware where you can club your quantum computers and GPU HPCs, CPU HPCs all together. So NVIDIA announces NVQ Link that they are going to launch, which will actually connect your GPUs to quantum processing units. So the cliffhanger that I told in our story is being solved using this kind of technology. So you can take a look at it and you can try to understand how these things are happening, but these are already widely being the people started widely manufacturing all these things and they soon go sell in the market. And these kind of controller boxes will sit in between your existing hardware and quantum hardware, and they will be actually acting as a bridge between your existing hardware and quantum hardware. So you don't need to throw out all the investment that you have already kept in or already invested in quantum, HPCs and all these things. You can simply buy these kind of controller boxes or the previous one, and you can be able to, integrate both of them, and you will be able to solve hybrid problems, and you will be able to execute hybrid models. And of course, you will be wondering if this is so costly, how can we learn and how can we make the students learn? Hopefully, these things become miniaturized, and this particular company is giving, quantum boxes of desktop kind of. If you look at the size of the box, it is almost similar to, thrice your laptop size in length, and width, however, will be more. So these kind of boxes are also being manufactured so that you can actually buy one and sit inside your lab and you can do it. So for superconducting qubits, this kind of setup, if you see in the bottom right corner, along with the HPC facility, there is a quantum computer. So for this, you require a cryogenic cooling systems, whereas for these kind of room temperature accelerators, you don't require that much cooling. But these are not scalable. These are fixed. If you buy for 5 qubits, you'll get only 5 qubits. Whereas superconducting, you can scale your qubits. That's how people are keeping all these superconducting qubits on cloud. IBM. I'll show one of the examples, and you can pay as you go. It's like a cloud service that is going to be started. So with that, I'll stop my presentation here, and from now I'll be walking you through different websites, different resources. I'll open directly, and I'll also paste the links in your chat box so that you can make a note of those links. So I hope I took almost 1 hour. Uh, so if we need to break, we can break for 5 minutes, and or if you want me to continue, I can continue. So I would request the organizers to suggest me on this so that I can. Yeah.
Continue, sir.
Okay. Thank you, ma'am. So these are the different resources to learn about quantum computing, especially if you are looking for designing a curriculum, or if you want to start this quantum culture in your universities and colleges. So these are the best books to start with, especially the extreme left side. The first book, Quantum Computing for Computer Scientists. This is a brilliant book where they draw inferences between quantum computing and classical computing while explaining. It it consists of all the physics behind the quantum technologies and everything. It's a kind of complete book that you can start reading. And of course, it's a difficult book. It involves lots of physics and things, but for computer science people who are not much exposed to physics, this is the best book. You can recollect all your physics skills that you had during your intermediate. So this is the best book. And next one is Quantum Computing and Applied Approach. If you want to learn quantum computing, not quantum physics, not in depth, but reasonably moderate and good, you can start with Quantum Computing and Applied Approach. So this is a good, very good book. Again, it consists of all aspects of quantum that you need to learn. And now, if you are not at all a book person, you learn everything using programming. And if you want to learn only based on programming, you type some programs, you get some output, you try to infer it. If you are that kind of person, you can select quantum computing for programmers. It consists of all the simulation programs that you can simulate to understand the quantum concepts. So that is another best book. And fourth one is Quantum Internet. I mean, people who are doing on quantum networking and all these people will be wondering how can we use this in networking and cybersecurity. So this is the best book. So the Quantum Internet, the second quantum revolution. As I told, this is the second quantum revolution at present we are in, where the technology is developing very rapidly, and you can see how the quantum bits can be used in order to transmit the data, and how to compress or you encrypt or whatever. So this is one. And there are other websites, Quantum Open Source Foundation. Let me open that. So this is another website. In this, if you see list of open quantum software projects, you'll be able to see what are these are all, by the way, open source. And you can see under each category existing open source projects that you will be able to use them and contribute to. So starting from quantum computing, developing quantum algorithms, quantum compilers, quantum internet, post-quantum cryptography, everything, you can see that. So as I told, many researchers, some of them are straightaway research products by different universities. You can also plan such kind of thing. And as I told, there are widely ongoing developments. So this particular websites let you get the latest articles on quantum. So if you see quantum classical integration for high performance computing, so all these things, so very latest papers, you can just click on these articles and you will be able to read these articles and part. If you don't get this article here, you can go to that particular how do we say, the publication house, and you can read these articles. You have all good resources related to that particular topic. And you see all the latest articles here. And coming to the news, so what is the latest news related to quantum? You can find it here. And the publications, specifically the research papers related to that. If you see, the very latest research papers are listed here. And events you can abroad, in India, whatever, you can all actually go and attend, looking at them. And you'll be interested in what kind of quantum jobs that are being created: quantum software engineers, quantum measurement engineers. So mostly a combination of electronics and computer science. There are many jobs related to that. Senior researcher, quantum algorithms. So all these things. Even there are PhD student opportunities available. So you can also find, if you are really feel that you are very good at quantum physics and all, you can also apply as commercial system validation verification scientist. So like, you can consider this is a very very new technology. That's why you can see very basic jobs also on this. It's like 40 years back how the classical computing used to be. That's how this quantum computing is at present. So there are multiple you know jobs also related to quantum. And there are good books. You can take a look at all these books. Of course, everything is available on internet now. And yeah, there are multiple videos, latest talks that are happening related to quantum and all these things in this particular website. So you can encourage your students to browse through these websites, so that it will be easy for them to understand what's happening in quantum around the world. And yeah, so those, of course, you can hashtag on LinkedIn. Uh, you will get latest, and if you follow those channels, you will get latest topics. Of course, Twitter, sorry, X, and this LinkedIn, and even nowadays Perplexity, ChatGPT kind of things also. They browse internet and they fetch you good internet links for these topics. So this is how the existing resources are, and these can be used for your design of curriculum. And next, I would like to go to a few more links. I'll copy paste all these things, or I'll share with the organizers all the material that I'm presenting to you today. So NVIDIA CUDA-Q. So this is a quantum processing unit agnostic platform for accelerated quantum supercomputing. So this is how CUDA-Q works. So like, if you have, as I told you, you have already the hardware existing, and if you want to simulate quantum, or if you want to add additional hardware using quantum or whatever, so CUDA-Q is a kind of a framework where you will be able to integrate both of your classical and quantum things. So they have wide resources how to do this. And if you see, uh, if you simulate quantum on a normal processor, and if you simulate on GPU, there is huge difference in the CPU, speed. So B200s are the latest ones, Blackwell series. And there are also starter kits you can explore. You can read the blogs. You can, run the notebooks, which consists of the code, all these things. So if you have a GPU system, and you can install this CUDA-Q framework, and you start simulating quantum bits. So this is all for simulation. And if you have hardware, and if you want to integrate your quantum computer to the existing hardware, it goes back to the previous discussion we had on how to integrate these two using the controllers. So this is a very good resource. You have multiple use cases, and you have Kodaku learning resources. See, nowadays all these companies are freely giving all the resources to learn because they want to get people used to their own hardware or whatever, so that they will have the demand in the future. So back in 2018, I used to get 16 qubits for free by IBM Quantum. Now even one getting 1 qubit is difficult. So you should buy and you should pay for that. So all the latest news on this you can actually try. And next one is, this is a very sorry, uh, very useful resource. If you are completely new and you don't know anything about quantum, and you somehow want to start as a computer science student or computer science researcher, you can use this code book. So this code book will have a map from where you can start and where you can go. So you have introduction to quantum computing, and you can sign in and you can actually start coding. There will be concepts as well as programs together, and you will be able to learn what is quantum and all these things. So this is how it looks like. I would recommend this particular, code book uh, if you are really interested in starting about quantum. So this is how you can look at the theory, and here you can practice the code. So once you sign in, you will be able to access all these. So this can be in your curriculum as a code exercise, or you can design your lab curriculum around this particular, it's a kind of manual kind of thing. You can plan using this. So this I specifically I like this because they gives you the map to learn what after what topic. So after this topic, you should be learning this single qubits, then multiple qubits. After learning multiple qubits, you can learn Hamiltonian thing, or you can learn basic quantum algorithms, or you can learn noisy quantum theory, variational quantum algorithms. This is what I explained today. Variational quantum algorithms, one of the existing uh, variants of quantum algorithm. So that's how you will be able to learn in a particular way. You will be able to find which direction you can go and all these things. Without that, you might learn randomly some topics and you will be confused how to relate. So, but this is a very good map where you can learn very uh, peacefully. Of course, they have separate Penny fundamentals. This is only for sake of framework. But if you learn these things, you can use any framework available on internet like Qiskit, Cirq, Penny whatever. So this is what I would recommend you to start working with in order to learn. And of course, Penny, as I told many times, Penny is about how you actually want to work with quantum machine learning. So this is a very widely and quickly developed, and I have seen many versions coming. I used to use version 6 during my PhD. Now it's version 44. So that level of rapid developments. And the beauty of this particular thing is, if you install plugins, irrespective of what is your code, you will be able to execute it on any hardware. So there are plugins for this, and you will be able to install those plugins. And again, there is lots and lots of resources for this. If you go to the documentation, you will be able to see what we can do with this Penny. I guess the website is slow. But this particular penny lane consists of multiple modules that can solve problems in chemistry, that can solve problems in machine learning, and all these things it will be able to solve. Uh, Especially, I wanted to show the plugins. So, yeah, so it's open now. So the beauty of this particular thing is that you will be able to execute along with the existing hardware. If you see, you will be able to do neural networks, you'll be able to do quantum circuits, club the output, again send it to a quantum computer or a classical computer or a quantum processor. So this kind of provision will be available in with this. And if you install these plugins, you'll be able to work with all this hardware. So these plugins are designed in such a way that irrespective of what the code you are using, you'll be able to connect to all these devices. They partnered with all these devices, and whoever is manufacturing quantum processors, uh, you'll be able to execute all your code irrespective of what your code is. They'll convert the plugins will convert it to that machine compatible. So that is the advantage of Penny. And if you look at Penny Lane, there are multiple devices. Even you will be able to execute or simulate qubits on GPU. So you have multiple devices, and Lightning.GPU is another device. It's a GPU extension of Lightning Qubit. It's our most perform all-round device for heavy workloads. And as I told, it is integrated with quantum CU quantum, so the CUDA quantum that we have discussed previously. So with that development kit, it actually gets integrated. So like there are wide range of possibilities if you start exploring. And of course, uh, this is the kind of website where I used to work for free, but now it's not free anymore. So everything we need to pay as we go. So advantage of this is you will be able to create your own workloads, your own API keys. You can connect your programs to the IBM devices. Okay, so especially here we have access to only three quantum processing units, and available qubits are 156. And you should definitely buy some credits in order to execute all these. So for our location, they are giving only three instances. And in order to use these quantum computers, you need to buy the credits. So your plan can be like you buy some credits here, write a penny lane program, use the plugin, and execute it on this particular hardware. So that means it's very hassle free. You should work only on penny lane. You don't need to bother about the hardware. So somehow you'll get the output using those penny lane plugins. So this is again a beautiful quantum computing platform where you can actually start directly working on quantum computers of IBM. So I think government of Andhra Pradesh is also establishing a 133 qubit quantum computer in Amravati Quantum Valley, so by IBM. So they have recently announced in Supercomputing India conference also that they are establishing this setup. So these are some useful resources. I did not point to Google resources also, but Google also has different plugins, different what this frameworks and everything. So you can also go to this particular website and you see what kind of developments are happening in quantum. Of course, Google also manufactures quantum bits like Sycamore processor, which is very famous back then, 53 qubits. So now they are manufacturing Willow, uh, and they are improving. Of course, it's manufactured. They are trying to improve this processor output. So this is the next generation quantum chip. You can also read the white papers for that particular how they are correcting the errors. So as I told, I did not go in depth of quantum physics because these qubits are very error prone. These quantum corrections, all these things happen. I did not go to that level details. I considered the audience mostly will be from computer science background or something. So this is what I planned for. So coming to the quantum networks, if you are interested in quantum networks, this is one of the very famous quantum computing platform for quantum networks, where this is developed by world's renowned quantum network research group, which is in TU Delft, Denmark. So this is NetSquid. So it's a tool where you will be able to install, what we call these quantum simulators for network. So for network simulation and all, we have different tools in classical network simulation and all. So you can consider this as a quantum network simulation tool, NetSquid. So if you look at the team, as I told, these are a bunch of different scientists that are from different universities. But this quantum research group uh, is is actually developed by TU Delft. There's a quantum research group there. So and you can look at the documentation. So you can download the documentation and you can work on it. So there are discussion tabs and all these things. So yeah, and now you will. It is like a Changeworks is like a platform where if you want to compare your quantum outputs themselves. So say for example, uh, if you want to compare the output of Sycamore processor or the Willow processor to the output of IBM's processor. And if you have, if you feel that you can solve one problem on photonic qubits and one problem on superconducting qubit, now you need some platform in order to facilitate that particular scenario. So Strangeworks is a kind of platform where you can submit multiple workloads at the same time, look, compare, or analyze whatever. So Strangeworks is another such kind of intelligent platform where you will be able to do things on the same platform at the same time. Okay. So you can say again, this is commercial, absolutely. You can create workflows. As I told, this is how the dashboard looks like, and you will be able to submit multiple jobs and you can analyze and you can do pipelines where output of one job gets into the input of another job. So all these things are absolutely possible using this particular thing, right? So yeah, this is Strangeworks. So now I would like to show, of course, this is a old demo, but I still wanted to show that things are possible because now if I want to execute these demos, I require some credits on IBM Quantum Computer. But as I told, these are the things that I'll be sharing. So these are the textbooks I recommended. and these are the links I recommended. Of course, Amazon is also having a quantum processor. Amazon uh, Bracket is a kind of platform where people start hosting quantum chips on these platforms. So this is such kind of platform. Uh, Give me 1 second. Yeah. Uh, is my screen visible still?
Yes, you can proceed.
Yeah. Okay. Thank you. So, if you want to do hands-on on quantum computing these things, so you can even do it on a Google Colab thing. So you can just install Penny I have installed Penny 41. This is an old notebook. I did not run it again because in order to execute this again, I need to buy some credits on quantum IBM quantum thing. So this is a old notebook, so you can install Penny and you can uh, before this I will actually do this. Yeah, as I told, Penny is a Python based thing, and you will be able to simulate this kind of things. And yeah, so you can install Penny, and once it is installed, you'll just import the package and you start creating quantum circuits. So this is usual Python programming templates. You can look at the Pennyline documentation in order to do that. And device here stands for a quantum simulator or a quantum processor that you are going to create the circuits on which you want to execute. So, and then you start running this, I'm just quickly walking you through all these things because I'll share all this information with you so that you can try it on your own. So
Okay,
then,
Avinash,
yeah,
uh, sorry
yes,
to
ma'am.
pause you. It seems you are not sharing your screen.
Oh, give me a second. Yeah, is it visible now?
Yeah, visible.
Okay. So, yeah, I'll start from the beginning. Okay, so this is how you can execute on Collab also. So you can install Penny and you can start writing the circuits and then you can execute them using these decorators and you can get the values. And if you want to execute the same on Qiskit or the IBM platform, you have, as I told you, have plugins and the plugins can be installed. After installing these plugins, you will be able to execute the things using the token. I executed on IBM Manila quantum computer, but now it's not available. So now it's just IBM quantum. There are multiple quantum computers, and this is how you can actually get the values out of real quantum computers also. And what if you want to encode an image onto that? So this is how you will be able to encode an image in order to impart image into qubits. And I have used this image, the famous image for image processing. And what I did is I imparted this image, I flattened the image and I imparted the image onto 16 qubits. Of course, this is a simulation. It's not a real quantum processor. So after imparting and the qubits or encoding the qubits onto the quantum simulator, I executed a quantum circuit. So this is the quantum processing. So after the quantum processing, I just tried to measure and I got some values. So I can consider these as quantum features. What we can consider is I have taken this image, uh, made it encoded on a quantum circuit, and then I executed quantum things on quantum processor, and I got the output. So this is how we can actually put data on the quantum processors. And now the variational quantum circuit, if you want to create a quantum neural network, so this is how you can do again. You can install PennyLane and you can actually create layers as I have shown in the PennyLane thing. You can actually create the layers. Let me do it again. So, meanwhile, so these are the layers where there are classical layers and quantum layers uh, together, and I reduce the layers so that I can save some credits. So, but you can actually create this kind of circuit using this code. So, where you have classical, quantum kind of layers. So this is how you can actually create. So if you see, this is a quantum input. And now for the quantum layer, I have created a circuit. And then what I did is I actually created the neural network, which consists of classical layers as well as quantum layers. So this is classical, quantum, classical. So just to save some credits on IBM quantum computer, I did this. So finally, I created a classification framework, quantum classification framework, where there is training data and there is test data, and it ran for 2 epochs, and so finally it gave some output. This output is not there at present, but this is the code that you can use in order to execute that. So this kind of experiments help you to simulate this kind of circuits. Okay, so yeah, I think I came at the end of my presentation and the things I want to discuss. So if the audience are having any queries, I would be happy to answer. And uh, yeah, uh,
Thank
if
you, Dr. Avinash. And the participants, if you do have any questionnaire or any doubts, if you want to have any clarification from Dr. Avinash, it is open for discussion. Or even you can pose your queries into the chat box also. Okay, it seems there are no queries to be answered. Thank you, Dr. Avinash, for accepting our invitation and sharing your experience and expertise in quantum science and technology to enhance our skill set. And thank you for sharing all the necessary resources, all the links, and showing us the right direction to excel ourselves in this area. And in future also, we are expecting few more knowledge sharing sessions from you, and we'll be collaborating with you in further sessions also. And
okay, thank you.
once again, Dr. Avinash.
Thank you for
and,
the opportunities. If you can, if somebody wants collaborations and all, they can connect with me on LinkedIn. So I'm happy to collaborate.
Definitely. And thank you all the participants for your patience listening, patience learning also. We'll meet next week with another topic. Thank you.
Thank you.